Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Please like, share, and subscribe my channel. Today we'll talk about the atomic models through history. Everything began with the Greeks. 460 BC, the concept of the smallest particle was conceived in the 5th century BC by Leucippus of Miletus. His pupil Democritus of Edinburgh developed 5 major points that their theory was based upon. Historians have discovered this from the quotations of the Greeks. Most of the original documents by Leucippus and Democritus have been lost. The 5 points Democritus conclusion: all matters made up of indivisible particles that are called atoms, which means indivisible. There is a void which is empty space between atoms. Atoms are completely solid. Atoms are homogeneous with no internal structure. Atoms vary in size, shape, and weight. Aristotle and beyond, 380 to 322 BC. In the 4th century BC, we well-known philosopher Aristotle vehemently argued that the atomic theory was completely incorrect and was therefore dismissed by the scientists for many decades. According to him, there were 4 elements: fire, water, earth, and air. In fact, the Catholic Church agreed with the Aristotle position and announced that atomistic ideas were equivalent to those of godlessness. Democritus of Abdera said that there is no end of the universe since it was not created by any outside power. A gap of around 2,000 years passed by. Leibniz is widely considered as the father of modern chemistry. He mostly worked with gases and was very precise in his measurements. It is discovered that although matter many changes, its form or shape, its mass always remain the same. This is known as the law of conservation of mass. John Dalton, models of 1803. John Dalton, an English teacher, is now called the father of modern chemistry. His model of an atom can be represented by the compact sphere. All elements are made up of atoms. Atoms of an element is identical in their masses. Atoms of different elements have different masses. Atoms only combine in small whole number ratios. Atoms can be neither created nor destroyed. John Dalton model 1803. Interesting fact: the unit of atomic weight was called a Dalton from many years. Today it is used in biochemical circle. Example, the atomic weight of that protein is 35,000 Daltons. With example, you can see one oxygen atom of 16 mass unit. When combined with 2 hydrogen atom of 1 mass unit, it will form 1 water molecule at 18 mass units each. 16 mass unit plus 2 mass units will give you the product of 18 mass unit. Joseph John Thomson, 1898 to 1904. Joseph Dalton Thomson, an English physicist, discovered that cathode rays were negatively charged particles, which he called corpuscles. We call them electrons. These particles had a mass about 1,000 times smaller than hydrogen. These corpuscles were the thing from which atoms were built up. Joseph John Thomson. Thomson designed a famous plum pudding model with a positive mass represented as white in a picture, and negative particles inserted as red sphere. Positively charged pudding and negatively charged plums. In another diagram, you can see that the spherical cloud of positive charge and having electron, which is in blue, having red color. Ernest Rutherford, 1910. Ernest Rutherford studied under J. Thomson. He was the first scientist to propose the theory of the nuclear atom. His famous gold foil experiment, watch the video below, provide that the atom had a positive charge where the mass was concentrated and the electrons were surrounded. Most of the atom is made up of empty space. The nucleus is 10,000 times smaller than atom. Ernest Rutherford, 1910, he was not able to specify how electrons were arranged around the nucleus, but he imagined a sort of planetary system around the nucleus. He took a radioactive source and then he allowed to pass and put a gold foil in front of the radioactive source. The detector and the beam fall on a gold foil and he observed a special kind of conclusion. The experimental setup for Rutherford's gold foil experiment, a radioactive element that emitted alpha particle was directed towards a thin sheet of gold foil that was surrounded by a screen which would allow detection of the deflected particle. Rutherford found that a small percentage of alpha particles were deflected at large angles, which could be explained by an atom with a very small dense positively charged nucleus at its center bottom. Niels Bohr's model, 1915. Niels Bohr came up with the orbit model or planetary model in 1915. It is referred to as the planetary model. The electrons orbit the nucleus like the planets orbit the sun. Each orbit can have a fixed number of electrons given by the formula of electron number is equal to 2 into n power 2. N is the shell of the level. Electron belongs in their natural state, ground state. They jump to a higher energy level if they receive energy and jump back to the ground state, releasing the energy in the form of light. Erwin Schrodinger, 1920 to 1925 quantum model. In the 1926, Erwin used math to describe the probability of finding an electron in a certain position around the nucleus. This atomic model is known as quantum mechanical model of atom. Electrons do not orbit around the nucleus like planets around the sun. They can be anywhere in a cloud link zone around the nucleus. An electron will occupy levels and sub-level of energy with different shapes. Heisenberg uncertainty principle. He described the atom's structure using pure mathematics. He created matrix mechanics where the order of multiplication matters. He published his work in 1925 in the breakthrough paper. In the subsequent series of papers with Max Born and Pascal Jordan during the same year, this matrix formulation of quantum mechanics was sustainably elaborated. He is known for the Heisenberg uncertainty principle, which he published in 1927, which says that it is impossible to know the position and the momentum velocity of an electron at the same time when you think you know one of them. The other changes. Heisenberg was awarded in 1932 Nobel Prize in Physics for the creation of quantum mechanics. James Chadwick, 1932. James Chadwick confirmed the existence of the neutron, which Ernest Rutherford predicted that, but he could not prove. James Chadwick proved that this radiation consisted of a natural particle with about the same mass as a proton. By shooting alpha particle, helium nuclei at beryllium in 1930. Scientists noticed that a strong penetrating radiation was emitted. Jazakallah for today. Assalamu alaikum wa rahmatullahi wa barakatuh.